Okay, hello everyone. I'm gonna sit down here and take this contingency table quiz and see how it does. I've got my Excel spreadsheet here because that's a nice calculator. It's contingency tables, and those are tables that have numbers on them. And remember last time there was all this given that, and so I needed last time I mean in class when we were talking about contingency tables. We needed to find row sums and column sums and stuff like that. And so I'm going to go ahead and make sure I've got Excel ready for this quiz. Okay, let's see. So, yeah, let's go ahead and get started. Okay, it started. The assessment has a time limit. Oh, okay, that's nice. It gives you a warning like that. All right, here we go. Enter. Okay, please answer the following 2 questions. You have 15 minutes to complete the test. You will have 1 attempt at each question. So be careful. Open note, open book, open internet. Please do not receive, not open internet. Please do not receive any help from another person. Okay, very good. That's fine. All right, I'm going to go ahead and, okay, let's see. Oh, well, now let me see now. Okay, so I could just type in the table. All right, let me just type in the table. 3659 tab 707012 enter 4408 tab 03053. Okay, let me look at those. Is that right? Okay, looks pretty good. All right, it's just a 2 by 2. I'm going to need totals. Okay, equals that plus that. Enter. Let's see. Okay, hard press, fill, there. All right, now I'll do equals that plus that. Enter. All right, and then hard press, fill, that way. All right, looks good. Okay, so there's my totals. So this is killed, not killed, used, not used. All right, A. Right? Okay, I think I'm ready. Use the table in the data in the table is from a study on mortality reduction with airbags and seat belts on head-on collisions. It organizes the results of an observation study. Use this table to answer the following questions and input answers in as a decimal rounded to 3 decimal places. Okay. If one motorist is randomly selected, what's the probability that he or she was using a seat belt? So that's going to be used seat belt divided by total. Enter. B. What is the probability? What's the probability of a randomly selected motorist what is the problem of selecting a motorist and getting one who was not killed given that they were not using a seatbelt. Given they were not using a seatbelt. Okay, so so equals. Okay, so not killed, that one. Given you not using a seatbelt. So that's that one. So among all the people that didn't use a seatbelt, 3,053 were killed. Okay, so there's that. All right, C now. Find the probability of randomly selecting a motorist and getting one who was killed, given that they were not using a seatbelt. So among all the ones, wait a minute. Did I get that one wrong? Not using a seatbelt. So B, that they were using a seatbelt. Okay. Let me read B again. Given one not killed, given that they were using a seatbelt. A seatbelt was used. All right. Okay. There. All right, that's better. Seatbelt was used in B. Okay, now C, find the probability of getting a motorist and getting one who was killed given they were not using a seatbelt. So that's that. So, okay, equals that over that. All right, D. Let's see, A, B, C, D. All right, equals. Okay, if one of the drivers is randomly selected, find the probability of getting a driver who used a seatbelt or was killed. Used a seatbelt or was killed. So I'm going to be adding up. So used a seatbelt, that one, plus that one, or was killed, plus that one, divided by the grand total. All right, so I think that's that. That's that one. Did I divide by the grand total there? Yes, I did. Okay, good. All right, now I'm at E. If one of the drivers is randomly selected, find the probability of getting someone who did not use a seatbelt, and was not killed. Okay, did not use a seatbelt is this one and this one, and was not killed, and let's see, plus that one, close parenthesis, divide by grand total. All right, I'm thinking so on that one. If one of the drivers is randomly selected, find the probability of getting someone who did not use a seatbelt, not use, okay, and was not, okay, I think that's good. I'm moving on. All right, F. If two drivers are randomly selected without replacement, find the probability that they both used a seatbelt. Okay, two drivers, okay, equals, this is going to be this one squared. Did not prove that they used a seatbelt. So used a seatbelt. So that's used divided by grand total squared. Because it's twice, and I'm using the cumbersome calculation guideline because the sample is only 2. The sample's 2, and the total is 18,000. So 2 is much less than 5% of 18,000. So I can use the cumbersome calculation guideline and pretend that they are independent. If 3 drivers are randomly selected without replacement, find the probability that none of them are killed. So that's none are killed. So that would be not, okay, equals parenthesis, not killed divided by grand total times 3, because there's 3 of them, and they're going to be effectively independent because of the cumbersome calculation rule. I'm going to press enter there. All right, now I'm going to type them all in. 0.589, okay, rounded to the nearest third decimal place. 0.657, 0.591, 0.5, no, 0. What am I? I'm on D. 0.831, 832. This one here is E. So this is 0.798. This one here is 0.346. And this one down here is 0.171. Let me just check those really quick. Looks good. Looks good. D looks good. Okay. 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 Submit. 6 out of 7. Huh. I think that one might be keyed wrong. All right. Next question, please. Okay. This question is with regards to the last two parts of the previous question. It's a little hard to remember what those were. Did the 5% guideline of cumbersome calculation apply? Why or why not? Well, I do remember thinking about that because it did say without replacement, and so they would be dependent normally, but because the sample size was small enough, let me just write that. Okay, so the answer is yes, because the sample sizes of 2 and 3 were less than 5% of, 18,000, because that, yes, the guideline applied and they could be considered independent samples. Concited. I don't care about spelling. No one's going to get marked off for spelling. Considered independent samples. I say yes, because the sample size of 2 and 3 were less than 5% of 18,000. Okay. The guidelines applied and they could be considered independent samples. All right, I think I'm going to go ahead. I'm happy with that. Submit that, and I guess I'll just go ahead and say done, and I'll investigate that last problem. See, did I make that one? Is that a cube? Well, did I make a mistake? No, I think it's... I make a mistake? Not killed. No, for the total. I think the question's wrong. Okay, done. All right, resume. I guess I don't need resume. Okay, I guess I'm done. All right, everybody. Okay, yeah, so that quiz was quite tight. It definitely was not comfortable. So, anyway, but, of course, I want us all to know the material fairly well, and I feel like quizzes like these incentivize us studying pretty good. So, however, I do want to make sure that we know this material. I don't think this is just sort of like a one and done sort of a quiz. So if you would like, so everybody has the option, I'm going to provide the option for this and future content quizzes to be taken mastery style, as in next weekend you'll have the option to take it again and replace your score. I think the essay question will be slightly different. The other question, the table's randomized, and so I think that will be sufficiently different. I may switch up, what you're looking for, use seatbelts, not use seatbelts, something like that. But it'll be very, very similar in that you'll be asked to do the same thing with the same 7, with the same 1, 2, 3, 4, 5, the same 7 questions. Just to ensure that we really understand this conditional probability and how these probabilities are obtained. And then the cumbersome calculation guideline is used enough that it's fairly important, and so it's a nice thing. Okay, yeah, so that's what we've got in front of us. Okay, everybody. We'll see you in class.